We're going to explain Markovnikov's rule because Markovnikov was actually looking at the final product. He was not looking for a carbocation. He was just actually seeing, look, the hydrogen went to one of the carbons of the double bond and the halide went to the other. So whenever you actually think about Markovnikov's rule, think about the most stable carbocation. That's not the way he said it, but right now in 2012, that's what we know. It's the intermediate of the reaction. So let's just go ahead. And again, we're going to add HCl or HBr or HI to our double bond. We're going to add the hydrogen to one of the carbons and the halide to the other. And we're going to form a carbocation intermediate, but we want to see which carbocation is more stable. We will always form the most stable carbocation. So, if we were to add the hydrogen of the HCl to carbon number 1, we would end up with 3 hydrogens on that carbon. The positive charge would go to carbon number 2. Now, that carbon has a hydrogen as well, so let me go ahead and draw it so that we don't get lost. This carbon is attached to 2 other carbons, so this is a secondary carbocation. If we do the opposite, if we put the hydrogen on carbon number 2, you put the hydrogen on carbon number 2, the positive charge would go to carbon number 1, and the carbon that's positive is attached to one other carbon, so this is a primary carbocation, and primary carbocations are unstable, so we're not going to be forming this. Again, when you try to obey Markovnikov's rule, think about the intermediate carbocation. Unfortunately, that's not the way he worded it. The way he actually explained his rule is that the hydrogen of the hydrogen halide will go to the carbon of the double bond that has more hydrogens. So we'll follow that because that way we will get the most stable carbocation. Once you finish the reaction, remember the halide will go to where we had the positive charge, to the carbocation, and this reaction right here will get you 2-chloropentane.